Hi guys, it's Mr. Stark again. I want to go over the AND circuit. So the AND circuit is if button A and button B are pressed, you will get a desired result of the LED coming on. So let's take a look at the schematic and then we'll look over the breadboard. So you can see how I've got some stuff that's labeled. The electrical schematic is just this one line straight down with this line and this line. This line, this line, and this line. Everything else over here are symbols. So you can see I have a 9-volt battery source right there. I have a resistor. I have a light emitting diode. There's my LED. By the way, all my resistors are 330 ohms. I have 2 transistors. One here, there's a symbol for a transistor. Another one here, there's a symbol for a transistor. The way these sit in the electrical symbol, your base is the middle lead. Then you have the collector, which is one lead off to the left and another lead off to the right. It's called the emitter. And then there's the direction. We have a base, emitter, and collector on the other one. If I was to show you the transistor close up, you can see that there is 3 leads and base, collector, and emitter. So, with that being said, let's go through the circuit. We have a positive 9 volts, comes into the resistor, goes through the diode. So the resistor is limiting the amount of current to the diode. And at this point of the game, these electrons are sitting right here at the collector, and they can't do anything until button A is pressed. There's a current limiting resistor on this end of the push button, so that we don't put too much voltage to this. So we've got a little bit of voltage coming to here, and right now this excited voltage, so to speak, will close up this depletion area, the NPN junction, and will allow these electrons to kind of get across that gap. Out the emitter, so here we go, we made it through here, out the emitter, into the other collector. Once again, we have electrons sitting here. We can't do anything until we press this button, which allows a little bit of some good electrons coming through into the transistor. Now we've got these electrons kind of building up, closing up that region, and allows for the circuit to be complete. So how that looks on the drawing, we have a positive terminal, and if you scroll all the way across, this resistor is hooked up to positive. The other end of the resistor comes over here to the positive side of the LED. It goes through the LED off the negative side of the LED. If we look at the drawing that represented that, positive coming into the resistor, goes through the resistor into the positive side of the LED, comes out the negative side of the LED, and now we're looking for this to go into the transistor collector side. Go back over to this. There's the negative side. It has to pick up a wire jumper to make it all the way over to this transistor. And if you look, it connects to one side of the transistor right there because it's on the same side, same row. If we look at that, the base is connected to this switch. There's a contact on here you can't see. The base is connected to the switch. We come back over. Here's my base connected to one contact of my switch. If I look at the other side of the contact of the switch, it's connected to a resistor back to the positive, which would be represented by this contact right here, touching this side of the resistor, and that limits the current flow from this side of the power source, and there's my positive. So that takes care of that. We want to look on the emitter side of that same transistor. There should be a jumper wire going over to the collector. Over here, we have the emitter side of that transistor. There's my jumper connecting over to the collector of this transistor. The base, once again, is hooked up to a switch. The switch is hooked up to a resistor back to the power source. That's this line right here. Base is hooked up to the switch. Switch is hooked up to a resistor back to the power source. We need to stimulate this transistor, so to speak. And if we look at the other side of the collector of that transistor, it goes to negative, which is completing my circuit. If I look at this side right here, there's my emitter. It goes to a jumper wire to get me over to negative, and negative is right there. So how does this work? Well, we need to press A and B at the same time to get this to work. That's the AND circuit. If I press just A, nothing. If I press just B, nothing. Let's represent that by a graph. So here's our 0 representing off, or the button not being pressed. The 1 representing on, or the button being pressed. Button A, if A is not pressed, and if B is not pressed, the button, which means they're off, I will get no light output. LED is my output. If button A is not pressed, but button B is pressed, I still don't get a light. So you can see this when I press button B, I get no light. So here's button B, no light. I come back. If A is pressed, which would be on, B is not pressed, I don't get a light. Same thing, press A, no light, B is not pressed. I come back over here. If A and B are on, or the buttons are pressed at the same time, then I get an LED output, which my light should come on. So if A and B are pressed, my light comes on. There's your AND gate. That's the logic. Two things have to happen in order for that light to come on. Hope you got something out of this, and I'll see you at the next video.